In this video, we want to start to take a look at the ideas of correlation versus causation. And this is very important here in section 11.1 because when we take a look at the different problems that we've looked at so far, we've seen a lot of different potential relationships that have formed. And it's important to keep in mind that there could be a lot of different variables that might influence a specific outcome. So in this case, maybe I say I return to the list of variables that could influence a person's final exam score. Again, there's a lot of different things that could impact this that are qualitative and some things that are quantitative. Notice in here that grades on other exams might be quantitative. Number of hours spent studying, number of credits taken, number of hours worked, number of hours of sleep. But some other things like your stress level, your did you have a good breakfast, or prerequisite math knowledge, that is going to ultimately be quantitative or qualitative stuff. So again, we're going to have some important key pieces of terminology here. An association is going to exist between variables when one of them is related to the other in some way, and this sort of phrasing can be used with any type of variable. We're going to reserve this word of correlation as a word that is going to exist or is a word that's going to be used when a relationship exists between paired quantitative variables. So notice that this word can only be used with quantitative variables, special word that we go ahead and use. Now, what that means is that if I was to look back at any of the previous examples that we've looked at in this section, and let me scroll back really quickly, I might be able to say that there's a correlation between number of hours studied and final exam scores. I could say there's a weak correlation between representative age and percent of people that perform volunteer work. I could say there's an extremely weak, almost non-existent correlation between height and annual income. So I can use this word, but only if I have two variables that result in quantitative values. What's very important to understand, though, is that when I see or do not see a correlation, I have to be careful about implying this other word of causation. Causation occurs when changing the value of one variable causes, and I should have an extra S on there, but causes the other to change. This word can be used with any type of variable, but must be the result ultimately of a designed experiment. So we'll take a look here in a moment at what I mean by this idea of correlation and causation. But ultimately, the fact that two variables have a strong correlation, the fact that when I look at their scatter diagram and I look at the value of R and I see really good linear relationships, does not in itself imply a cause and effect relationship. In fact, a lot of questions that I might want to ask if I was ever conducting some sort of a study is there a cause and relationship between variables? Does X cause Y? Does Y cause X? That's a very valid question to ask. But I might also be interested in, is there possibly a third variable or perhaps a combination of several other variables that help to explain the relationship? Is it possible that the relationship between the two variables may be purely coincidental? So we'll see here as I take a look at example number 5, how exactly this comes into play. So let's suppose the data was collected from many countries around the world to see if the average number of TVs per household could be used to predict the average lifespan for people in that country. Let's suppose there was a strong positive correlation between the average lifespan and the average number of TVs per household. Okay, so I'm going to go over here and just start to kind of jot down what it is that I might have seen. So if my input variable was my average number of TVs, my output variable was my average lifespan. So notice this corresponds to exactly my explanatory and my response variable. So my explanatory variable was the average number of TVs per household, and my response variable is the average lifespan And again, remember that we're doing this per country. So you can imagine asking these questions about different countries in the world, right? So maybe you go to like the US, you say average number of TVs per household. Maybe it's like pretty high amount. And you say average lifespan. Maybe that's also a pretty high amount. So maybe like the US gets a dot right there. Now, if you go to some, very poor third world country, maybe the average lifespan is a lot lower, and maybe they also don't have a lot of average TVs per household, and so maybe there's a dot down here. But other countries are going to get other dots, and they're going to be kind of all sprinkled around, and I can see that there might be some sort of a relationship that begins to get formed. And so maybe it's the case that there is a strong positive relationship between these variables, maybe something kind of like this. Okay. So to say that these variables are positively correlated really just means that what we can see is as the number, or sorry, I should say as the average number as the average number of TVs increases, we see that the average lifespan increases. So this is just what we've been given in the problem. And our question is to try to understand, or at least the thing we would typically be asking here is, why is this happening, right? Again, here, this is just a description of what it means to say there's a positive correlation. As one thing goes up, we are observing that the other thing goes up. But part C then asks an extremely important question. Do you think that increasing the number of TVs in a country will cause the average lifespan for people in the country to increase? Like, actually imagine this, right? Like, maybe, you and I or the US itself, we got a bunch of TVs. So maybe we like load up a bunch of TVs and we put them all on a plane and we fly them over to some third world country and we just start, shoving TVs out of the plane. Maybe we attach a parachute to them so they don't just plummet to the ground, right? But we just start like just distributing TVs to countries, right? So imagine, you're in a third world country, you look up one day and all of a sudden there's like, 50,000 TVs on parachutes coming down towards the ground. Now, that country might just be able to have increased their average number of TVs per household. Is that going to cause the average lifespan for people in the country to increase? Well, this is absolutely a ridiculous scenario. Like, obviously, no. There's no way that just because you have more TVs, you will live longer. So, what we're seeing is that there is not necessarily a cause and effect relationship. By giving someone more TVs, it doesn't help them live longer. But that doesn't change what we're seeing in the picture. We're still seeing that as the average number of TVs goes up, the average lifespan is going up. So the question might be, what are some lurking variables that may be present in the study? What is it that could account for the fact that because a country has more TVs, they also have people that live longer? What thing can account for both of those? Well, one thing that might be really obvious right away is income level. The income level of a country would allow people to purchase more TVs and maybe allow them to purchase better healthcare, afford better quality food, have a gym membership, all of these sorts of things. So income level might actually be something that is a better predictor of both of these things. That is, income level might be causing the increase in TVs, or at least having a more direct causal link. But by itself, it doesn't seem that there's a causal relationship between the two variables as stated. This can be something that is seen all over the place. And in fact, in the next video, I'll show you a interesting website that you can try to take a look at to see some of these other kind of weird coincidental potentially relationships.